so this says solve using any method. When you get to test time, it'll tell you to solve using any method. Of course, remember, graphing is not a good choice, so we're going to stick with either substitution or elimination. Are going to be our most accurate choices algebraically. If you have problems like this one where you have fractions, but there are no variables in the denominator, it's just numbers in the denominator, which they all are here. A good, let's call it optional, but I would say suggested first step is to multiply something through any equation where you have the fractions, okay? You want to multiply by a common denominator. Ideally, it would be the least common denominator, but any common denominator will work, okay? So what's the common denominator in that first equation? 6. Okay, what's the common denominator in the bottom equation? 8. Okay, so top equation by 6, bottom equation by 8. The 6, think of it like a 6 over 1. It's getting multiplied by the numerator. When we multiply fractions, numerator times numerator, denominator times denominator. So I would do 6 times x, and then it would be over 3. You can do this in your head. 6x over 3 reduces to 2x. If you are doing this right, you should get whole numbers every time. Okay? 6 times y over 2. What's that going to give me? 3. Y, open it's a minus for that term. And then in my last one, 6 times 1 is just 6. Okay. On the bottom, 8 times 3y on top gives me 24y divided by 8. Gives me 3y. And I'm actually going to put it there, positive 3y, because I know I'm going to want everything lined up eventually anyway. So I might as well save myself some time. Okay. 8 times x over 4. 8x over 4 reduces to 2x, and that term is negative 2x. And then finally on the other side, 8 times negative 3 gives me negative 24, divided by 4 gives me negative 6. And now that is like the problems we did yesterday. So now you have a choice. Would you prefer to use elimination or substitution here? Elimination. Everything's lined up. It's not super easy to get a variable alone. And look, you already have those opposites. Positive and negative 2, positive and negative 3. So you don't even have to multiply by anything. You can just add your equations together here. What's going to happen on the left if I add those together, the x's and the y's? 0. What's going to happen on the right? Also 0. This is one of the special cases we talked about yesterday. If all of my variables cancel and I get a true statement, 0 does equal 0. Yes. What does that mean? Infinitely many solutions. So if you were to look at these lines, if you wanted to check it, you could graph them, and they should be the exact same line. A good way to graph these would probably be with Desmos. So y is not alone already if you want to check that. Okay. Any questions there if we've got a number in the denominator? All right. Let's see what happens then if we have a variable in the denominator. These are tricky now. We can't just multiply through the least common denominator because the denominator is a variable, and the variable could be something like 0. And if the variable equals 0 and I'm multiplying by 0, I'm going to lose answers or get false answers. We're going to have these mathematical errors that occur. So we have to find another way to solve this. Now you can, if you're really great with fractions, solve this using elimination. So let me show you that way first. I actually already have opposite terms in this problem. Do you guys see that? I have a 1 over y and a negative 1 over y. You can just add these together. Okay, my y's are going to cancel. I know I'm going to get 6 on the other side. When I add 3 over x, I'm going to write that out. 3 over x plus 6 over x is what I need to add. When you add with a common denominator, the denominator stays the same. So if I had like 1/5 and 2/5, my answer is 3/5, right? It's all still fifths. Denominator stays the same. But 3 and 6 give me 9. So 9 over x equals 6. Now, that 6 is over 1. I'm going to write it like that because this should look familiar from Algebra 1 or Algebra 2. Is it a proportion? We can cross multiply to solve that. So if I cross multiply, 6 times x gives me 6x. 9 times 1 on the other side gives me 9. X equals 3/2. And that's the first part of my answer. 3/2. Second part of our answer, we have to plug 3/2 back into either of the original equations. I'm going to use the top one. Okay. 3 divided by 3/2. Dividing by a fraction is gross. If you remember doing that, instead we multiply by a reciprocal. If you remember simplifying those, you could also use a calculator for this calculation. But 3 divided by 3/2 is the same as 3 times 2/3. 3 times 2/3 is 6/3, and that gives me 2. Plus 1 over y is 4. Subtract 2. 1 over y gives me 2. What does y have to be to give me 2? Any thoughts? Can you do that in your head? Has to be 1/2. If you don't see it, you can again cross multiply. Think of it like a 2 over 1. 1 times 1 gives me 1. 2 times y gives me 2y. Divide by 2, we get that 1/2. Okay. All right. So this is what we would do if you want to solve using elimination. And if I didn't already have opposites, you can do what we did yesterday, multiply a number through to get opposites. Okay, but you can completely solve with elimination. I would not recommend substitution if you've got a problem that looks like this. I would stick with elimination. Or I'll show you one other way to do it. I like this method the best. I will tell you that. Okay, similar type of problem. Variables in the denominator. What I'm going to do is a fun little replacement step, we'll call it. I am going to create 2 new variables, and I'm going to call them u and v. That's because that's what our book uses, but literally you could call them anything you want. You want to call them a and b, that's fine. But don't use x and y because I already have an x and a y. I'm going to let u equal 1 over x and v equals 1 over y. And you're going to use those same substitution pieces every single time. Why am I choosing 1 over x and 1 over y? Because if I see 6 over x, that is the exact same thing as 6 times 1 over x. I can take that term and break it apart. So instead of 6 times 1 over x, I can just write 6u. And instead of 3 over y, I can think of it as 3 times 1 over y, or 3v equals 0. So it gives me these nice pretty whole numbers. I can do the same thing with the denominator. Instead of 4 over x, I can think of it as 4 times 1 over x, or 4u. 9 over y is the same as 9 times 1 over y, or 9v equals -1. And now that we can solve just like yesterday. So I'm going to multiply, and you have choices here how you want to do it. I'm going to multiply the top by -3. If I multiply the top by -3, I get a -18u, a -9u, and 0 times anything is still 0. That gives me -14u equals -1, and therefore u is 1/14. You can then plug that back in to get v. I'll use the top equation. 6 times 1/14 plus 3v equals 0. That's 6 over 14, which is 3/7, plus 3v equals 0. Subtract 3/7. 3v equals -3/7. Dividing by 3 is the same as multiplying by 1/3, and you will end up with v is -1/7. Those are not our final answers. That's what u and v equal. Back at the top, we can use u to get x, and we can use v to get y. I can say, instead of u, 1 over x is 1 over 14. Because u and 1 over x are the same thing. So what does x have to be? 14. And if you don't see it, you can cross multiply. Instead of v, I can say 1 over y is -1/7. What does y need to be? -7. And then you can plug those back in and make sure they work. Okay, so you have 2 choices when you see a problem like this. You only have to worry about it when there's a variable in the denominator. If you want to use elimination, great. If you want to use, and it can be this exact substitution every time, great. But either way, you got to be good with fractions. They're not going away. Okay. Any questions on our fraction systems? Wonderful. Okay, the last 3 things that we're going to talk about, we're going to just practice setting up some equations that you could then solve with substitution or elimination, okay? But we're not going to actually solve them today. We're just going to practice setting them up. Solving you guys can do on your own, practice for homework. All right, so my first system we're going to write says Levon paid 40 cents for each string of beads and 30 cents for each doubloon he bought to throw at the Mardi Gras parade. He paid a total of $265 for the two items. Combined, he bought 770 beads and doubloons. How many doubloons and strings of beads did Levon buy? Okay, so number one, when you're solving a problem and you need to write the equation, you need to figure out what are my variables? What are the things I'm solving for? What am I solving for in this problem? Okay, beads and doubloons. And you can call the variables whatever you want. If it's me, I'm not using X and Y because then I might forget which one's X and which one's Y. I'm going to use B for beads because then I know exactly what it stands for, and D for doubloons because I know exactly what it stands for. Okay, now your job is to write two equations. Both equations have to have a B and a D in them. Let's start with a total. That's a good way to work backwards. Give me a total that we have in this information. 770 beads. Now that is a number of beads. So how do we get that total? It's the number of beads plus doubloons. It's our items, right? It's not really a bead total. It's our item total. So the number of beads we bought plus the number of doubloons we bought is 770 items total. Okay. What's our other total that we have in this information? 265. That's a dollar amount. So this is where your cost is going to come in. So that's how you know what to put in which equation. If it's my dollars, 40 cents is, how do I put that in an equation? What number do I use? 0.4. So 40 cents per string of beads. Per means multiply. Plus 30 cents per doubloon, however many I buy, equals $265 total. And that's your system that you can solve. If I were doing this problem, here's what I would do. I don't like decimals when I solve these. The first thing I would do is multiply that bottom equation by 10 because it would move all my decimals one space over and I would have whole numbers. And then you can solve it however you want. Substitution, elimination. Okay? Any questions on the first one? Just setting up our system. All right. We're going to do two more. Gunther invested $10,000 in two mutual funds. One of the funds rose 6% in a year and the other rose 9% in a year. His investment rose a total of $684 in 1 year. Find the amount he invested in each fund. Okay, first thing I need to know is what are my variables? What am I solving for? What am I solving for here? The amount he invested in each fund. And this one, it doesn't matter what you call them. I'll call them Fund A and Fund B. Okay? That's how much money I'm putting into each fund. Do I have any totals I can work backwards from? Here. What's a total? 684 is how much, pretty much interest we earned. How much my account went up. And then do I have any more totals? The 10,000. This was our investment. Okay. So how much money did we invest? Well, that's what we're solving for. A plus B. We put A in the first account, we put B in the second account, and I invested $10,000 total, or Gunther did. Okay. The interest, bless you, is where we're going to include our percentages now. So Fund A rose 6% as a decimal, 0.06. So 6% of whatever I invested is going to be money I earn. Plus Fund B is 9%, times 9%. And then you have your equation. If I were solving this problem, the first thing I would do is multiply that top equation, not by 10 this time. What would you need to multiply by? 100. To move the decimal 2 spaces to the right, to have all whole numbers to make it easier to solve. That would be my first step. Questions on that one? Okay. The third one is yours to try with a friend. I'll give you a few minutes. Figure out the two variables that you're solving for and then write two equations to represent this situation, a system we can solve. Go ahead.
Are they adding it together? Just what? Because like, is it just like what they had for the day and they just divided it down? So that's like going to
Now you can use whatever letters you want, okay? But in mine, M stands for McDonald's and T stands for tutoring. So I will tell you, very, very common mistake is people flip these because of the way the sentence is worded. It says the student earns twice as much tutoring than at McDonald's. So where do they make more money at? Which should be bigger, tutoring or McDonald's? Tutoring better be bigger. So if you have 2 times T equals M, is tutoring bigger? That doesn't make sense, okay? So it's kind of worded backwards the way we say those sentences. You got to think about what's bigger. If something's 2 twice or 3 times or something like that. Now, if I were going to solve this, which you didn't have to, if I were going to solve this, I would probably use substitution because the T is already alone, which is good. And I would multiply this top equation by 2 because then I could get that fraction to cancel like we practiced. Okay, those would be my first couple steps. So that's up to you. All right, and that is everything we didn't get to yesterday for section 8.1. That is it. So your homework for 8.1 is due on Tuesday night next week. And then 2, 3 was due last night. Yeah, you guys already did that one. So this is the only homework you got to work on. You have 25 minutes now to work on it. I'm going to pass back to you your quizzes, your partner quizzes. You may keep them. If you got an A or a B, you got a sticker. 2 stickers for your partner. You need to see them, okay? I tried to mark where you went wrong. I promise you, things that are on your quizzes will be on your tests, okay? Keep them, study them, correct them, ask me, go to the library, Mrs. Caldwell, use your notes, whatever you need to do, but you want to know what mistakes you're making on the quiz when it counts for a little bit versus the test when it counts for a lot. Right now, this quiz looks like a lot in the grade book. It's because there's only 2 categories right now. We have homework And then we have this one quiz that's counting for half of your grade right now. Overall, quizzes are only 12% of your grade. Once we get a test in there, you'll have a better, range of what it looks like. It looks like a lot right now, but there's just not a lot in the grade book right now. So don't panic if you look at your grade that's low, it's just because this one quiz is counting for half right now, but that won't be the case throughout the semester. Okay? But keep those. When you see the skills test went in as a homework grade, I do need your skills test back. Okay? So don't put that in your notebook. You guys are going to put it back in the tray after you get it. All right. Okay. Yeah. Did you turn it and get it all? Okay, then you do it, submit it. Yep. All right, now and let's do our cell phone